we're back. Ooh, it fizzed for a second. Okay, now we're talking about scale factor. I need to find a better way to teach this because I feel like I don't teach it super well. Also, on the document, this side is first, and then this side is second. I start with this side normally. Maybe that's wrong. I don't know. Let's just talk through it. So, okay, we start with two-dimensional things and three-dimensional. They're three-dimensional partners. For example, I should put this Play-Doh away. Our square, its three-dimensional equivalent is the cube. Our circle, 3 dimensions, sphere. Okay, like extending it out another dimension in all the ways. Okay, so what we do first is I pretend like my length and my width or my radius is 1 unit. And then I figure out what my area is for each shape with no scale factor. So I'm not multiplying by anything. I do the same thing here. Okay, so here my area was 1 unit. Here my area was it was just pi units. Here my volume was 1 unit cubed, and my volume was 4/3 pi units cubed. Then I go in and I multiply the dimensions by a scale factor of 2. I make everything bigger. I double the size. So here, instead of my side lengths being 1, now they're 2 because I've multiplied each side length by 2. This will end up giving me an area of 4, okay? Similarly here, I have 2 squared as my radius instead of 1 squared like before. I get 4 pi. Here, I have my length, width, and height. Each of them is 2. So my scale factor was 2. I multiplied my 1s by my 2s. I'm taking each my length, my width, and my height, and I'm multiplying them all by 2 to get my new lengths. And then I'm figuring out my volume from there. Same thing here. My original radius was 1. My R was 1. So I multiply that by 2 because that's my scale factor. A scale factor is just something that you multiply by. I end up getting a new radius of 2. Then my new volume is 8 times 4/3 times pi. Now, I could go on explaining this over and over. We do a scale factor of 3, then 5, then 10, okay? With 3, I take my original length, width, or radius, multiply it by 3 to get my new. My original was 1. Every time your original is 1. And then I'm seeing what happens. Then on the back of this sheet, we have a summary chart, okay, where I look at where I multiplied each of the scale factors, okay? When I changed my length by the scale factor, I just multiplied by that number. So when my scale factor was 2, it doubled. 3, it tripled. 5, it quintupled maybe. 10, it multiplied by a factor of 10. When I changed my area, I'm looking at how it changed my area each time. So I looked at, okay, my area was 1, then 4, then 9, then 25, then 100. I put all those numbers in here. So 4, 9, 25, 100. What I ended up doing is I'm multiplying my scale factor multiple times within that area. So I'm going up exponentially, okay? 4, 9, 25, and 100 are all perfect squares, okay? 4 is 2 times 2, 9 is 3 times 3, 25 is 5 times 5, 100 is 10 times 10. Because I have each of my dimensions already multiplied by a scale factor, I'm raising that scale factor by a power. So this ends up raising the scale factor. The 3 scale factor goes up by a power of 2 for the area. Okay, so the area is going to change by a factor of the scale factor to the power of 2. Okay, then with my volume is a 3-dimensional property, and so I am multiplying my scale factor 3 times in a row. So 2 times 2 times 2 was my scale factor here. So I got 8. 3 times 3 times 3 ended up giving me my scale factor 27. 5 times 5 times 5, 10 times 10 times 10. Okay, so I'm taking my scale factor and I'm cubing it to get the factor that I have to use to find my volume. Okay, um, hopefully this makes sense. I will try to give you pretty easy problems. If you have specific questions about this, please post them on the discussion board. I'll be happy to answer your questions. I feel like that could help clear things up a little bit. Scale factor is a little bit challenging to figure out. So um, do not hesitate to ask questions, but this is a key concept that you do need to know for Math 3. So um, comment on the discussion board, ask me questions. I'm sure there are plenty of questions. I put the filled in version of these notes. Take your time and go through each one and see if you can see the patterns, okay? So when I just change the dimension, look at how I changed the dimension for each thing. When I change the area, look at what my areas are each time. I have 1 unit, 4 units, 9, 25, and 100. When I change my volume, look at the factors that are common between my cube and my sphere each time I change the scale factor. Also notice that no matter which shape I used both a square and a circle and a cube and a sphere on purpose because I wanted to show you that this property holds true with any shape. I know that this is not a proof for any shape because we only did 2 out of the infinitely many 3D shapes and 2D shapes that there are. But this property does hold true. So go ahead and look at that and try to go through in detail and look at what I did. And please ask as many questions as you have. Okay, well, I hope you guys are doing well, and I hope that today goes well. Let me know if it doesn't, and I can try to remediate for our Flex Friday. All right, have a great evening or day or evening or whatever it is for you. All right, bye.